All right, hello. I'm going to be talking about rules of resonance, which will be important for organic chemistry. So this is for students to simplify things. So for the first rule, charges stay the same. What this means is that if your original structure has a charge of zero, then your other resonance structures needs to have a charge of zero. Next is the major. A lot of times in your organic chemistry classes, they'll say major or minor. And so what that means is it's going to be the most common structure and it's going to be the most stable. And so the major one is usually going to have the one with the least amount of charges. The next rule is going to be the octet rule. So what does this mean? This means that each atom has about 8 electrons on it. And so what that means is you don't want a carbon with more than 8 bonds. You want it to look uh, like a real structure. The next third rule is charge. The most electronegative atom is going to have the charge that corresponds with it. Um, and so these are some of the three rules that I use to solve resonance structures. I know that in the book or anywhere else, there's going to be more rules, but these are some of the three that's helped me. So this is just simplifying it down. Right, so now we're going to go on to some of the basics. One bond is equal to 2 electrons. Two bonds is going to be equal to 4 electrons being shared. Next is carbon usually has 4 bonds and oxygen usually has 2 bonds. And so this will be more important when we go closer to solving. So this is our original structure and the problem's asking to solve for the other two resonance structures with this. So this is the original. As we can see, oxygen and all the carbons have a charge of zero. How did we figure this out? So oxygen has 6 valence electrons, and then we subtract about however many bonds it has and however many um, electrons or lone pairs it has. So it has 2 bonds, and it also has the 2 lone pairs, which is 4. And so when you do that, it's going to equal to 0. So that's how we got a 0 charge for right here. Now for the carbon, the amount of valence electrons it has is 4. The way you get these valence electrons are looking for the periodic table. You'll be able to figure out however many that one has. Right, so carbon has 4 electrons. I'm talking about the center one right here. And it has 4 bonds. 1, 2, 3, 4. So we have a formal charge of 0 on there. Okay, so now let's talk about how can we get that extra, the other resonance. And so the way you do that is by seeing however many options you have to move electrons around. So what I would start with is this double bond right here. All right, so if we move this up, what happens? Well, I've written it differently right here, just kind of to emphasize that that bond is those 2 electrons moving. So when I move it up, this new structure forms right here. Right, so this is the other resonance structure that we have, and now we have to recalculate those formal charges. What do we have now? Right, so if we look at this oxygen, so it has the 6 valence electrons. How many bonds do we have? We have 1 bond, and we have however many lone pairs? 1, 2, 3, 4, 5, 6. Right, and so with that being said, we now have a -1 charge on here. Okay, now what about the carbon? We have the 3, and that's it, right? So we end up having a +1 charge on the carbon. So that is our new resonance, our second one. Now let's see if there's another one. You can start back at the original that we had, or you can start at where we were at, where we're at right here. So you can start right here or in the original. It just depends on what you want. So we're gonna start on the original one that we had. So we originally had it like this. And now, so what can we do now? What we can do is we can move these two electrons and put it to itself. And so what do we get from that? Well, we end up getting something that looks like this. So we still have those two electrons at the top there. But now we have the two electrons right there. It looks really weird, right? And it's supposed to because it doesn't make any sense. But let's recalculate everything again. So if we do 6 minus the 1 bond and then the 4 on there, you're going to end up with a +1 charge. You know what about the carbon? For 4 valence electrons minus 3 of the bonds. And then we have those two lone pairs on there. All right, so we're going to end up getting with a -1 charge on there. But we're not done yet. Now we have to figure out which one is going to be the major, which one's going to be the minor. And this is going to be important for all your organic chemistry classes. They're going to ask you which the major, what's the minor. The way you do that is by looking back at the rule set that we had to begin with and to deduce that. So let's look back at the rules. So the rules say the charge stays the same. Does the charge stay the same for all of them? The original, everything's supposed to end up at 0. So if the original has a charge of 0 total, let's look over here. We have a plus charge and we have a minus charge. When you put those together, it ends up it's a 0 charge. For the third one, you have a plus charge and a minus charge. When you put them together, it's 0. Now we're going to the octet rule. Do they all have octets? Yeah, they do. They all end up having an octet in them. For charge, oxygen typically has the negative charge on them. So you want to have it on there so we can rule out third as being an important one, just because that positive charge is on the oxygen. The negative charge is on the oxygen, which is typically how we can see it, which is just like that. So now which one's the major and which one's the minor? We said that the one with the least amount of charges is going to be the major. So as we see, the first one right here has 0 charges in comparison to the second one. Therefore, the first is going to be the major. And the second one is going to be the minor. All right.